can start. Thank you very much for coming for our traditional, let's say, research seminar. And today is very happy, very proud to host Sергій Mелещук, who is a PhD student from University of California, Berkeley. And before that, he is a graduate of the National University Beyond Pareto and also Kyiv School of Economics. And his research covers the topics of macroeconomics and also international trade, very relevant topics for the central bank, at least for the emerging market, for the national economic. And today, Sergey is going to present his research paper wrote with his co-authors on the topic of the intensive margin trade moving beyond Pareto. And this paper established the novel several aspects on the size of average export across multiple regions and destinations, which may be of particular importance for the selections of relevant theoretical frameworks from heterogeneity in context of international trade. And of course, taking into account the importance of the diversification of exports in Ukraine, I think his research would provide some insights in this area. Okay, Sergey, the floor is yours.
Thank you very much. Thank you very much for the invitation and for the introduction. So this paper is written jointly with Anna Fernandez and Denise Pierola from the World Bank, who did a lot of work collecting the data, and also professors Andrесом Родріґез-Кларе and Pete Klino. And a usual disclaimer applies. The views represented in this presentation are of the authors and do not necessarily represent the views of the World Bank or its member countries. We will use a novel data set collected by the World Bank, the Exporter Dynamics database, to take this prediction to the data and see how well the model does at this point. And we will continue with some other observations. So we would like to point out that the prediction that most variation or all variation in export comes from the extensive margin is robust to multiple extensions. So we can take the model of Eaton, Kortum, and Kramarz with demand shocks and fixed cost shocks. I will talk about it later on, and the convex marketing cost extension. We can take non-CES preferences, non-constant elasticity of substitution preferences. We can take non-monopolistic competition, or we can add multinational production. In the Melitz's model with all these extensions, the prediction of extensive margin being the main driver or the main explanatory variable for total export holds. We cannot break it. Our paper is related to the number of papers that use Melitz-type models to study the firms in international trade context, but the main difference is that first, we use a lot of origins and destinations that are in the EDD data. Most other papers either use one origin, and so they are unable to establish the stylized facts that we do. Also, we will use the maximum likelihood estimation of the parameters of the log-normal model of distribution of productivity. To my knowledge, most of the papers use the Pareto distribution, and this distinction will be of the most importance for this paper. Also, there is a number of recent papers that start using the novel EDD data. Some of the papers also argue that log-normal distribution is preferred to Pareto to explain some patterns in the data, but they use one, at most two origins to make their point. And they don't discover as many stylized facts as we do. Finally, one of the main implications of our paper is that when we move from Pareto distribution to log normal distribution of productivities, it changes the way we think about welfare analysis in trade and the way we calculate trade elasticities. Okay, so I would like to start with outlining what the canonical model or the Melitz's model is. Talk briefly about exporter dynamic database, show you the empirical facts that we want to explain and that we establish. And finally, we will look at one of the explanations, the log normal distribution of productivities today. We did we tried other explanations that didn't work. I will briefly mention them when we come to that point. Okay, so what is the canonical model in international trade? When we think about firms, we know that there is a well-established stylized fact that exporters are larger and more productive than firms that don't export. And the model that tries to fit these facts and does really well at fitting them has the following features. So firms there is a continuum of firms. They produce perfectly differentiated goods, and they compete monopolistically with each other. Demand side is very simple. Consumers have CS preferences, constant elasticity of substitution preferences with elasticity of substitution parameter sigma. The firms have different productivity. That is drawn from the Pareto distribution that we denote by capital G. And the shape parameter of this distribution is theta. The firms can sell domestically. They can also choose to export their goods to other countries. But if they do choose to export, they have to incur fixed cost of production, Fij, which doesn't depend on the amount, on the quantity of goods the firms want to export. And they also face iceberg cost of trade, or sometimes they're called variable trade costs, tau, if they want to sell from market I to market J. So the convention is the first index stays for the origin and the second one for destination. To briefly introduce the notation, we denote the total number of firms by capital N. We denote average export per firm by X. And we denote total export, which is the product of average and the number of firms, by capital letter X. So as I pointed out, even relaxing some of these assumptions, like monopolistic competition or CES preferences, will not overturn the main prediction of the model, so we will stick with this simple assumptions for the exposition. Okay. So doing some math, we can derive the expressions for the total number of firms that sell from country I to country J and average export of a firm that sells from country I to country J. And I would like to go briefly over these expressions and what they mean. So the total number of exporters from I to J well, it depends on the total number of firms of country I denoted by NI, on the wage in country I, or the cost of the input in production. BI is the lower bound of distribution of productivities. So we have the origin-specific component. We have another destination-specific component where this AJ reflects the market size in destination J. It's like a real income in destination J. And also we have trade costs. So the number of exporters is inversely related to the variable trade cost. So the costlier it is to sell 1 unit of goods from country I to country J, the fewer exporters will be. And the same holds for fixed costs. The higher fixed costs, the less there will be firms selling from I to J. And the intuition is if fixed costs or variable costs are high, it's not very profitable for firms that have very low productivity draws. So productivity determines the cost of producing a good. So firms with low productivity are less profitable than firms with high productivity. And for them, it might not be profitable to export if the cost of doing so is very high. Thus, we have a selection of the most productive firms when the cost of trade goes up. Another expression, which is much simpler, is the expression for the average export. And you can see it depends on some constant. So theta bar depends on two parameters of the model, the shape of the distribution and the elasticity of substitution. And Fij is the fixed cost of selling good from country I to country J. So to remind you, these fixed costs don't depend on the value or the quantity of goods that the firm sells. And the intuition here is the following. Well, the higher fixed costs the firm has to incur, the more it has to sell to break even on the exporting market. So it doesn't make sense for a firm to sell a small amount if fixed cost of exporting is high, because it won't profit from that. So if fixed costs are high, only firms that can sell a lot of goods to country J will do so. And low productive firms to sell a lot of goods will have to put a very low price on their goods, and it won't be profitable for them either. So this is a very stark prediction. It tells us that the only statistics that we need to know to infer something about average export is the fixed cost of production and some parameters of the model. So let us make some functional assumptions about variable and fixed costs of production. We can decompose them into the origin, destination specific component and some bilateral component that varies across I and J. So tau I, for example, is the same for all ij pairs if the origin is country I. And we do the same for the fixed cost of production. Another notation that I want to point out is we put tildes for the variables that were demeaned by origin and destination. Okay, so using these formulas and this assumption about fixed costs and variable costs of production, we can then express in logs the number of firms and the average export as this. So we have origin-specific component, which is this guy, and includes origin-specific components from fixed costs and variable costs of production. We have destination-specific component for the number of firms, and then we have components that reflect bilateral, variable, and fixed trade costs. While for log average export, we only have bilateral fixed cost of production, because variable cost of production, I want to point out, doesn't enter this expression in the canonical model with Pareto distribution of productivity. Okay, now we will use these expressions later on basically to uncover the implied trade costs. Okay. So having that expressions in mind, I want now to define the object that we call the intensive margin elasticity. So imagine you want to run a regression. You regress log average export on origin and destination fixed effects and log total export. And you are interested in this coefficient alpha. So how is that coefficient alpha interpreted? It just tells you by how much, well, if total export increases by 1%, what do we know happens to average export? So in the canonical model, we know, well, I will tell you what the prediction of the canonical model is. We can also express this coefficient alpha as the covariance between average and total export in logs that were demeaned by origin and destination, because we include origin and destination fixed effects, divided by the variance of total export. So another interpretation of coefficient alpha is how much variance, well, like what share of variance in log total export comes from the variance or comes from the changes in log average export. Okay, if we take the formulas from the previous slide and the mean average and export and the number of firms by origin and destination, plug them here, we get this formula that will be very important. We can express the intensive margin elasticity as a function of the variance of fixed costs, variable costs, and some covariance between the two. Okay? It will be clear a bit later why we need this formula. So this is a model-driven expression for the intensive margin elasticity from this regression. So in other words, we can write this regression, take here, take these two variables from the data, estimate alpha, and then say something about these objects over here. I want to point out that it's very hard to observe what trade costs are. And it's a concept that's very hard to quantify, but we can calculate this object by running this expression that should be driven by trade costs. Okay, so looking at this formula, we can derive two observations. So first, imagine that bilateral fixed costs are not varying across countries. So we allow for fixed cost to be origin and destination specific. So some origins might have high fixed cost of exporting. Maybe it's hard to sell from some countries. Some destinations might have high fixed cost of exporting. Maybe it's hard to export to those countries. But we don't allow for bilateral component. Then just plugging this expression in the numerator, we will find that IME is 0. This covariance will be 0, since this is a constant, and this variance is 0, so the whole ratio is 0. Observation 2, if we find that IME, the way we estimated, is positive, the only way this can happen is when bilateral component of trade costs, bilateral components of trade costs are negatively correlated. So why is that the case? Well, to have positive intensive margin elasticity, this ratio shall be negative because there is a minus sign over here. These variances are both positive, so this component has to be negative to be consistent with a positive IME if we find it. And I will show you in a couple of slides that it's indeed positive. Finally, well, not finally, but this is the expression that we had for, so please bear in mind these two observations. They will be relevant to the empirical estimations that we conduct later on. As we discussed, we can derive the expression for log average export as a function of origin and destination fixed effects, and the residual will be reflecting the fixed cost of exporting, the bilateral fixed cost of exporting from I to J. And so if we want to, say, project those fixed costs of exporting on distance, say, how does the bilateral component vary when we change the distance between different IJ pairs? This covariance will be equal to this expression. So instead of using fixed costs of exporting, we can use the demeaned average, log average export from I to J. So if, for example, average export falls with distance, then we will have the corollary that fixed costs of exporting are falling with distance. So if you see that Mexican firms that sell to Ukraine are smaller than Mexican firms that fall to the US, you might conclude that fixed costs of exporting to Ukraine are lower than fixed costs of exporting to the US from Mexico, and because Ukraine is much farther from Mexico than the US, you would imply that fixed costs are falling with distance. So were it true in the data, it's a bit puzzling. Like, why would fixed costs fall with distance? If anything, we would expect fixed costs to increase, trade frictions to increase with distance. Okay, finally, there is a fourth observation that we take to the data, and it's related to intensive margin, but at a finer division of the firms. So imagine that we take all the exporters from I to J and divide them we rank them and divide into 100 bins. So in each bin there is 1% of the firms. And then we can calculate average export in each bin, so in each percentile of the firm. So we can have average export of the smallest 1% and average export of the highest 1% and all the way through. Then we can run the regression that is very similar to the IME regression that I described above, but for each percentile. So for each, so we will have just 100 regressions like that. If we define this alpha as intensive margin elasticity for each percentile, the conventional canonical Mellitz model, as I described it before, has the prediction that this intensive margin elasticity is the same for all percentiles. Not only it is constant across firms, it's also constant, across origins and destinations. It should be constant across all the percentiles over the board of the firms that sell from I to J. We will also use these expressions that I derived a couple of slides back to uncover the implied variable and fixed costs of exporting. So taking the data on the number of firms and average export, we can get rid of these origin and destination fixed effects and making some guesses about these parameters, theta and theta bar. We can go from these statistics that we have in the data to the implied trade costs that we cannot measure otherwise. And then we can calculate, that's how we will calculate the correlation between them. So we are interested whether fixed costs and variable costs of exporting move in the same direction or not, and how they are related to distance. So we will be able to see whether the common sense assumption that trade costs are increasing with distance hold in this case in our data. The data that we will use comes from the World Bank. It's the exporter dynamics database. It's being constantly updated, and it's mostly anonymous, but a subset of country years can be available for researchers at their request. This data has annual trade flows disaggregated by firms, by destinations, and by HS six-digit products. So for example, we know where the Mexican firms are selling, which products they sell. So HS is an international classification of goods. So I think HS six-digit classification has roughly 4,000 different products, beverages, cars, or something more precise than that. So we know how much each firm sells each good to each destination that it serves. This data comes directly from the customs offices, so it's probably one of the most reliable data in economics. And if we calculate just total export, non-oil export, or manufacturing export of the countries in this database, it's roughly equal to the statistics published by UN Commission of Trade. So the data seems to be very good. The World Bank has additional data, Chinese firm level data. So China is not part of this exporting dynamic database, but we can use it in the in this paper. So with China, we cover roughly 12% of the world exports. And here is the list of countries. You can see most of the countries have the data in the 2000s. They're mostly not very big countries, with the exception of China, that come from Latin America, Africa, and Asia. Europe is underrepresented, but we have some European Union countries like Romania and Croatia might have been somewhere, or maybe not. Okay. So here are the first results that we get. On this graph, we plot basically log total export on the horizontal axis, and log average export and log number of exporters on the vertical axis. We demean the data by origin, destination, and also year, because we want to get rid of the fluctuations in prices. And the slope on this graph is equal to the intensive margin elasticity that we want to estimate. For these graphs, we used the sample we wanted to use the sample with the largest number of firms, so we only used 4 destinations and country pairs with more than 100 exporters. So we want to avoid country pairs with 2 firms or 3 firms. But the results hold for in broader samples as well. So what does theory predict these two graphs should look like? So theory predicts 0 slope of the intensive margin, the horizontal red line, and the slope for the extensive margin, which is the regression of log number of firms on log total export, shall be 1. While in the data, we definitely see that the slope on the left graph is greater than 1 and probably statistically significant. One explanation that might pop up in your head, why do we get this upward sloping relationship, is that different countries trade in different industries. So Mexican goods to the US can come from different industries than Mexican goods that come to Ukraine, and all we capture is the variation in the industry that compose the export from some origins to some destinations. So when we do the same regressions, but we disaggregate export by industry, we define industries. We define 15 industries, 15 manufacturing industries like textiles, cars, and stuff like that. So we have more observations, but still the prediction that intensive margin is positive holds. If anything, the slope becomes even more, even higher. So quantitatively, in our preferred regression with year, destination, and origin fixed effects, intensive margin is roughly equal to 50%. For the sake of time, I will not show you all the robustness checks that we did, but we increased the sample to include all destinations and all origins. We instrumented total export, our right-hand side variable, with the lag and lead and lag of itself to avoid issues that might be caused by the measurement error. So if some firms, for example, report higher export, we would both have higher average and total export, and we can have a spurious relationship between the two. So if it's a classical measurement error, instrumenting should deal with it, and we should get 0 coefficients in that case, but we don't. We disaggregated by industry. We also disaggregated by product. So we had 15 industries and up to 4,000 different products, and the result, if anything, become even more puzzling if we compare them to the predictions of the conventional model. We excluded small firms just to see whether there are some problems with measurement of export for small firms, and included more origin-destination pairs. The result holds. Intensive margin is positive and significant. Speaking about correlation between implied fixed and variable trade costs, we find it, under some assumption on the parameters, we find it to be negative and very large. And it's not driven by this choice of parameters. We tried different values, of parameters that were estimated in the literature, and we find negative correlation. So when variable trade costs are higher, it should be that if canonical model is true, that fixed costs are higher, are lower, which we find slightly puzzling. We also projected variable and fixed costs on distance, and we find positive relationship between variable costs and negative relations between fixed costs and distance. So we find this fact puzzling as well. Finally, the intensive margin coefficients for percentiles looks like an upward sloping line, while in theory it should be flat. Now we will try to come up with a model to explain all these puzzles, all these facts that we discovered in the data. We tried multi-product firms extension. We tried granularity. So granularity means that we don't have a continuum, but a finite number of firms, and there can be some countries that are lucky, have very high productivity draws for their firms, so it drives average and total export up. They don't work. So today I will talk about the log normal distribution instead of Pareto distribution as a potential explanation of this puzzle. So briefly, intuitively, why does it work? So let's start with this identity. Average export is equal to this animal. We have the ratio of average to minimum export, and in the canonical model, the minimum export is pinned down by fixed costs of exporting. So this is another way to say minimum export, so it cancels out. If we try to write down this ratio, given some distribution of productivities G, we get the following expression. So average export is proportional to sigma elasticity of substitution times fixed cost times some function h of phi star. What is phi star? Phi star is the productivity of an exporter, or the smallest exporter that finds it profitable to export. With Pareto distribution, this h function is just a constant. It doesn't depend on anything, on the number of firms or on trade costs. With log normal, it can be shown that this h function of phi star can also be expressed as a function of the share of firms that serve destination J. So Nij divided by Ni is the share of exporters from I to J. And this omega function will be increasing in this ratio. So the more firms you have selling from I to J, imagine that Fij is fixed for all country pairs. The more firms you have selling from I to J, the higher will be the average to minimum ratio. Since minimum export is fixed, the higher will be the average export as well. So log normal distribution naturally gives rise to the intensive margin. We increase the number of firms, maybe because variable trade costs are lower in some cases. We increase both number of firms and average export, and we have higher total export going along. So we have both intensive and extensive margin. We did some naive estimation of this simple log normal model. We imputed the share of firms that sell from I to J, an estimated parameter that determines the function omega. We found intensive margin at around 0.43, and we had the positive slope of the intensive margin for percentiles, but there was a problem. We were still getting negative correlation between fixed costs and variable costs of exporting. So before I switch to the more complicated model, I want to point several drawbacks of this simple model. First, only with productivity shocks being the only dimension of heterogeneity, we would have perfect hierarchy of destinations. So firms that sell to less popular destinations should also sell to the more popular destinations. The popularity of destinations is determined by the number of firms. In the data, we don't see that. We see some firms that sell from Mexico to Ukraine but don't sell to the US, the most popular destination. We have perfect correlation of sales across markets. So if a firm sells a lot to US, it should sell a lot everywhere. we see that this correlation is not one. And then minimum export shall pin down the fixed costs, as we discussed before. But we have a lot of firms with very low minimum export, which would imply that fixed costs of exporting are far too low. So that's why we wanted to allow for more heterogeneity in this model. We allow for demand shocks, which determine how attractive the firm's products are in the destination J and how much it can sell. And we added heterogeneous fixed costs. So it can be the case that firm can draw a very low fixed cost if its productivity is very low, and then it will sell a very small amount. And we see that there are a lot of small firms in the data that export. At this point, we don't allow any correlation between productivity, demand shocks, and fixed cost shocks for the firms. I want to say it's possible, using the log normal formulation of the model, it's possible to derive the expression for the likelihood function. And using the expression for the likelihood function, we will maximize it to calculate the values of the parameters that we want to estimate. So the parameters that we want to estimate are the variances of productivity, demand, and fixed cost shocks, and the parameters dij and mu fij that reflect variable and fixed trade costs. So in the canonical model, it was very easy to derive variable and fixed trade costs. With log normal model, it's a bit more involved. This likelihood function can be not strictly concave everywhere. It can have local minima. And we have a lot of parameters, so we estimate it using the Metropolis-Hastings algorithm. We restrict our estimation only to 2 destinations because it takes a lot of time. Now we are improving our estimation technique and add more origins and more destinations. But with this approach, we get both point estimates and standard errors of the parameters that we want. But it takes a lot of time to do that. Speaking about the identification of parameters, how do we identify the parameters? Well, in brief, total export and the number of firms help us to pin down variable and fixed trade costs, mean of the variable and mean of the fixed trade cost. The variance of sales within each destination is related to the sum of the variance of productivity and demand shocks. And the covariance of sales across destinations gives us the separate estimation of productivity, because we assume that demand shocks are uncorrelated across destinations, but firm productivity is the same for all destinations. So in other words, if there is no covariance, then it's all coming from demand shocks, so productivity variance is 0. And skewness of sales distribution will tell us something about the variance of the fixed cost of production. So all the parameters of the model will be identified. After we run the estimation using this full log normal model with productivity shocks, demand shocks, and fixed cost shocks, we did some tests to see how well the model fits the data. So we simulated basically the model, and we tried to see whether the distribution of export that we get is close to what we have in the data. So this is one origin, sales to the US from some origin. So the data is anonymous, and I don't really know which origin it is. And the 2 distributions overlap very well, and it's true for most origins and destinations, with some exceptions for small trading partners, for IJ pairs with a small number of exporters. We can also fit the fraction of firms that sell to the less attractive destination. So say there is firms that sell to the US and firms that sell to Germany, and how many of the firms that sell to the US, the most attractive destination, are also sent to Germany. So if in the data we see that 5% of firms that sell to Germany sell to the US, that sell to the US also sell to Germany, in the theory or in our simulations, we can get that statistics very close as well. So to conclude, we see a satisfying fit of the model to the data. When we move to estimating the intensive margin elasticity, in the log-normal model, we find that using our preferred estimates, it's around 0.6, not very different from 0.5. So 0.5 is in the confidence interval, using the unrestricted model. When we shut down bilateral variation in fixed cost of exporting, so we only allow for origin and destination components in the fixed cost of exporting, extensive margin goes up. So this tells us something, this will tell us something about the correlation between fixed and variable trade costs. And I'll mention it in a slide. This is the graph for the intensive margin for each percentile. The blue line is the data that I showed you at the beginning, and the red line is intensive margin elasticity that comes from the simulations of our model. The two lines are closely aligned. And finally, both fixed and variable trade costs are that we get. The bilateral component is increasing in distance, and the correlation between them is positive as we expected. So overall, the log-normal model fits the facts that we see in the data and the facts that we would expect from the common sense perspective much better than the canonical model. And the difference between the two is the distribution that we assume about the productivities. So you can ask me, well, why do we care? And it's a very good question. So we would, and the answer is that if you want to build an empirically plausible and relevant model with firm heterogeneity and international trade, you need to be able to fit the facts that we found in the EDD data. And otherwise, the predictions that you might have from that model, the thought experiments that you make with it might not be very realistic. So for example, there is a paper by Berman et al. In QJE, in which they study how much total export changes in response to fluctuations in the exchange rate. They do something similar. They also call it extensive and intensive margin elasticity, but it's elasticity with respect to exchange rate. So they find that in the data, very low extensive margin elasticity of export with respect to movements in exchange rate. They build a model with Pareto distribution, and that model gives them a higher implied elasticity of extensive margin in their case with respect to exchange rate. So we conjecture that if they use log-normal distribution, for example, of productivities, that they would be able to fit the elasticity that they get from the data much better. And then it would make their predictions of the model much more plausible and much more relevant for the policymakers. So to conclude, we used a novel data set with firm-level export. We find some interesting stylized facts that previous papers were not able to find because of the small number of origins of the data, of the small number of origins that was available. We find that these facts that we have is a puzzle for canonical Mellitz Pareto model with multiple extensions. And we can solve the puzzle if we allow for log-normal distribution of productivities, and we allow for heterogeneous fixed trade costs. So that the firms face. Okay, thank you very much for your attention. And I guess we have a...
Thank you very much. And the floor for Q&A session is open, so please.
I have a question. Thank you very much, first of all, for the presentation. It's very interesting and really informative, I would say. However, you have pointed out that in the full Mallet's normal model, the final model that you used, actually, you allow for two kinds of shocks, for demand shocks and for fixed cost shocks. Am I right?
Yeah.
Yeah, but you said that you at this stage you do not take into account the possible correlation between these shocks, but it would be probably more intuitive to follow this correlation. Do you try to simulate the model with these assumptions?
Yeah, thanks a lot for the question. So indeed, in other papers that use Pareto distribution, the authors allowed for correlation between demand and fixed cost shocks, and they argued it helped them to fit some other relevant facts in the data, mostly about small exporters. In our case, we don't do that for computational purposes at this point, and so we are not fitting that facts very well. However, now we are running a new algorithm in which we will be able to allow for correlation between demand and fixed cost shocks for each destination and for each firm. So we are working on that, and potentially it will make the model fit the data slightly better in other dimensions that I haven't mentioned here, and we will see what will happen to the intensive margin elasticity.
What are the policy implications of your paper, for example, for a country which is trying to boost its exports? So
it's very hard to say something about the implications for the policymakers that want to boost export. But this model tells you, so imagine that you add some tariffs here and you want to regulate your export with the tariffs. You get different predictions in the Mallet's model with Pareto distribution and in Mallet's model with log-normal distribution, especially on the extensive margin side. So for the policymaker, we claim that the policymaker should use model with a log-normal distribution of productivities if they want to consider thought experiments such as increasing or decreasing tariffs. And there are other papers that say that gains from trade, so moving from completely closed to open economy, are different depending on the assumption of the distribution of productivities. So quantitatively, the effect of increase in tariffs by 1% will be different in two models. We don't measure that, but we know it will be different. So to have a better understanding of what's going to happen, probably it's better to use the model with log-normal distributions. Yeah.
So your then the final model is log-normal and heterogeneous fixed cost. How much do you think the results that you get, that you can match the data, is accounted by log-normal distribution and fixed cost and heterogeneous fixed cost? If you just add heterogeneous fixed cost to Pareto, will you get the same?
That's a very good question. That's what we are doing right now, actually trying to see what happens with Pareto distribution and heterogeneous fixed costs. We can get intensive margin elasticity, positive intensive margin elasticity. Actually, even without heterogeneous fixed costs, we can get positive intensive margin elasticity if we allow bilateral fixed costs to vary. But we need to check, so we can get intensive margin that is the same in the data, but our conjecture is that we will fail in the percentile regression, so the slope of the percentile line will be downward sloping for some reasons. And also the intensive margin that we get in different samples by throwing away small destinations with a small number of firms, it will change in a way, in theory, it will change in the way that's opposite to what we see in the data. So we try to test exactly the model with Pareto and heterogeneous fixed cost and evaluate it on the similar dimensions. I would say log normal gives a lot of, is very important for all the facts that we try to fit. And Pareto is very tractable, but it's hard to break some very stark predictions.
Maybe it's like part of the previous question about normal distributions, because you explained how you are able to explain how the problems place with this change in the classical model. Have you faced something quite puzzling that you wasn't able to express with the normal distribution, and do you have some implication for further research on some curious things you found out during this investigation, which are not able to be explained by your assumption about it?
Yeah, actually, yeah, we did. We are not really able to explain the share, the number of the small exporters that we see in the data. So in theory predicts much fewer small exporters than there are in the data. And one of the ways to fix it is to add positive correlation between demand and fixed cost shocks. So you draw a very bad demand shock, so you cannot sell a lot, but you also draw a very favorable fixed cost shock for you. So you don't pay much to export, so you do export in some small amounts. So we are working in that direction as well. So there are some facts. I don't have it in my head. Also, something was about the correlation of sales of the same firm to different destinations that we were not able to match perfectly or satisfyingly. Yeah, so it's not perfect in all dimensions.
Well, we have one more question concerning the data, because you use very novel data, and I think this is very useful for the topic. But did you try to get some other data? For example, you said that you have the China data, which is not in this database. Did you try, for example, to get some Ukrainian data? That would be interesting for us.
Yeah. So we did, and Anna from the World Bank contacted some of the officials in the customs, but then there was some change in turnover in the people who work there, and so now she has to write to new people to get the data. She's constantly working on expanding this database, so maybe at some point we'll have Ukraine and some more developed countries. So yeah.
Ukraine is not available in this database.
No. There are some countries for which people used similar data, but EDD, the World Bank doesn't have the data. So there are some papers that use Danish, Brazilian, and US data and French data, but to get it, you need to be French, or Danish or Brazilian, just to work on site with the data. So,
for example, if we have trade data statistics on 10-digit level, is it possible to, but not on the company level, is it possible to switch them to
So we need the number of firms to calculate the average. For the MLE estimation, we need sales of individual firms. For the intensive margin regressions that we used, just average sales and the number of firms shall be okay. We are open to any suggestions and any hints on how to get any data from Ukraine.
For no questions, let's thank again.
Thank you very much for having me today.